Good morning. My name is Amit Singh, and in this video, we are going to discuss a very important topic, that is tropical cyclone. Cyclone as a whole is having some huge impact over the climatical pattern of Indian subcontinent, or more specifically, the climate of India. Because of that, it's also having some huge impact over the social as well as the economical aspects of our country, India. And anything which is having some influence over the geographical, economical, and social aspect of India automatically makes it important for the UPSC civil services examination, more specifically the main examination. If you scan the past few years, 5 to 6 year papers, you will find that every second year we are witnessing one question from the tropical cyclone in civil services main examination. If you go with the year 2024, 2022, 2020, okay, if you go with the case of 2020, they were having two questions in the main examination, one which is linked with the geographical aspect, and the other question we're having the question linked with tropical cyclone, linked with the disaster management. So on that year, we're having two questions linked with the tropical cyclone. That in fact, anything which is having some huge impact over the various aspects of India or the population of India is surely going to be asked in your main examination. So now you might be knowing that why this topic is important for the people who are preparing for the UPSC examination. Now, before getting into this topic, we just cover basic fundamentals, fundamental concepts, and also cover the meaning of cyclone first. Meaning of cyclone, which will help you to understand the main topic, that is the tropical cyclone, what we are covering in this video. Now these concepts are really important because that will help you to understand the mechanism that is linked with the formation of cyclone or the tropical cyclone. Okay, these concepts are, first one I'll take up, Coriolis force, and the second one is latent heat. Okay, so without having the presence of these two concepts, you can say, or the condition, it is quite impossible to have the formation of tropical cyclone, or without understanding these two topics, it is quite difficult to understand the mechanism linked with the tropical cyclone formation. Now I'll go with the first one. First is Coriolis force. So again, it's also a very important topic as per geography is concerned, but there we are having the application of this particular concept or the force. Okay. Now, if we talk about the Coriolis force, it's an imaginary force, okay, which develops because of the round shape and the rotation of the Earth. Okay. So what this force is all about? Now it is this force which makes any freely moving body moving over the surface of the Earth deflect from its actual path towards right in case of northern hemisphere or left in case of southern hemisphere automatically. Okay, so it is an imaginary force which deflects any freely moving body moving over the surface of the Earth towards right in case of northern hemisphere or left in case of southern hemisphere automatically. Okay, so it need to go straight, suppose. Okay, but what happened automatically, this particular body turned to its right, okay, or left in case of southern hemisphere, right? So there the force applied is called as, this imaginary force applied is called as Coriolis force, and this effect is called as Coriolis effect. Okay, or in other way you can say that this law developed, that means any freely moving body automatically turn to its right. Okay, so this law developed is actually called as Farrell's law. Farrell's law. So this force, we'll see that this force is having some huge application when we talk about the formation of a tropical cyclone. So that is all about the Coriolis force. We'll apply this part when we talk about the mechanism linked with the tropical cyclone. Now we go with the second one. Second is latent heat. So what is latent heat? Now the latent actually stands for hidden. Something hidden is there, hidden. Okay. Now it is that heat which actually been utilized during the change of state of any matter. Okay. So we know that over the surface of the earth, we're not talking about the inside part of the earth or any other part of the universe, but over the surface of the earth, we're having three states of any matter. And these states are solid state, liquid state, and the gaseous state. Okay. So any matter can change into solid, liquid, or gaseous state. Okay. So these three states are there: solid, liquid, and gas state. Okay. And this heat is actually been utilized during the change of solid to liquid or liquid to gaseous state. When we're having change of the state of matter, they were having the absorption of this particular latent heat or the hidden heat without having change in the temperature. So there it is helping in the change of state from solid to liquid or liquid to gas, but there is no change in the temperature of the matter, right? So in this case, when we are having change of state from solid to liquid or liquid to gas, there this heat get absorbed. We're having the absorption of heat, okay? Absorption of heat when we're having the change of liquid to gaseous state, okay? But if you go in the reverse direction from gaseous to liquid, from gas to liquid, or from liquid to solid, there in this case the same heat get released, okay? So there also we're having release of heat during the change of state from liquid to solid, right? So if you go with this part, liquid to gas, we're having absorption. From gas to liquid, we're having the release of heat, okay? Or in other way you can say that when we're having evaporation, during evaporation, they were having absorption of heat, okay? And during condensation, that time we witness release of heat in the atmosphere, okay? That is how when we're having some kind of thunderstorm, so before having some kind of rainfall, having the formation of cloud, okay, so they were having the condensation process going on. So during that time we're having increase of temperature because of the release of heat, okay? So just before the occurring of uh, the rainfall, we witness increase of temperature because of the condensation process. In this we witness the release of latent heat, which is more hidden over here, okay? So that is the second concept, that is the latent heat. So it is also having some huge importance when we talk about the tropical cyclone. Okay, you know, if you talk about tropical cyclone, this process of course a huge system. Okay, it's a huge manifestation of energy that you know, okay? So in this system, we requiring lot of energy. So from where we are getting this energy? So it is getting from the atmosphere in the form of latent heat. It is this heat only which is providing the proper energy for having the development of the system called as a tropical cyclone. So we go further. Now, of course, before getting into the tropical cyclone, we also need to know the meaning of cyclone first. Cyclone. So what is, how can we define cyclone? Okay. So cyclone is more a low pressure zone. It's a low pressure zone surrounding, or we can say surrounding which we're having the spiraling winds. Okay. It's a system of low pressure zone surrounding by the inwardly spiraling winds surrounding the low pressure. Okay. So this system as a whole is called as a cyclone. Okay. So it's a system of low pressure zone surrounded by the inwardly surrounding winds or the spiraling winds around the low pressure zone. Okay. So this as a whole is forming a system called as a cyclone. Right. Now this spiraling wind is also having some definite direction of the movement. Okay. So it is not, it is haphazardly moving of course in any direction, but what is happening, they also have, this wind is also having some fixed direction of movement or the spiraling of course. How to so? Now suppose if this cyclone is developing in the northern hemisphere, so this spiraling movement is anti-clockwise. Anti-clockwise, if you go with the case of northern hemisphere, so this circulatory movement of the wind is anti-clockwise in case of northern hemisphere, and if this is occurring in the southern hemisphere, then the movement is clockwise. Okay, right? So in case of southern hemisphere, so this circulatory wind is moving clockwise, right? Okay. So in this way, they are having some definite movement. So this system of low pressure along with the inwardly circulating wind around the low pressure combinedly called as the cyclone, right? Okay. So now, where the cyclones are developing, suppose this is the equator zone. Okay. So on the basis of the location of its formation, okay, so these cyclones can be divided into two types. So if you go with the types of cyclone, so on the basis of the location of its formation, it can be divided into two types. Okay, that is, one is tropical cyclone, and the second one is temperate cyclone, temperate, right? Okay. So where these cyclones are forming, on the basis of that we have simply segregate or divided the cyclone into two types, and these are tropical and the temperate cyclone, right? Suppose if this line is demarcating, as simply demarcating the equator, and these two are the tropics, Tropic of Cancer and Tropic of Capricorn, south. Okay. So if the cyclones are developing between these two tropics, that is the tropical region or near to the equator, okay, over this part, okay. So in that case, the cyclones are been put under the category of tropical cyclone because they are developing within the two tropics, in the tropical region, in the warm region or the torrid region. Okay. So this part is called as the warm region or the torrid region, or can be termed as tropical region. So the cyclones which are forming between these two tropics are actually being termed as tropical cyclone or categorized as the tropical cyclone. Now the one which are developing, okay, beyond the two tropics over here or here, then these cyclones become extratropical or temperate cyclone. Okay, so we categorize these all cyclones which are developing beyond the two tropics. They are termed as the temperate cyclone or the extratropical cyclone. Okay, so here on the basis of their location of formation, we have categorized the cyclone into two categories. One is tropical and second one is temperate cyclone. Now remember this part. Uh, it is not totally on the basis of the location of formation. Okay, but even if you check out the nature of these two type of the category of cyclone, types of cyclone, or their formation even. Okay, so their nature as well as the formation also differentiate these two types of cyclone. I'll go with the example. Okay, now in case of nature of cyclone, right? Okay, so they were having tropical, suppose tropical category cyclone. Okay, and the second one is temperate cyclone. So if you go on the basis of nature of cyclone, okay, so tropical cyclone is more having the destructive nature. It is quite destructive in nature, of course, because of its very fast moving winds. The winds are moving very fast. Okay, along with it is also having, it also produce some very heavy rainfall which almost develop the flooding condition where we are witnessing the landfall. Okay, so that is how, because of its nature, it's more destructive in nature, makes lot of destruction. Okay, or destructive in nature. Whereas if we talk about the temperate cyclone, most of the case the cyclones are human friendly, because as they move, they bring light rainfall, okay, which is very good for the agriculture system wherever it is simply influencing. Okay, so during the winter, it is simply influencing, it's simply having some kind of positive influence over the agriculture system. In case of India, we're having the winter crops or the rabi crop. So it is good for the rainfall which has been produced by the temperate cyclone is good for the rabi crop. So it is simply supporting in the food security. So that is how it has been taken up as the human friendly nature. Human friendly. Okay, so there also we're having the contrasting difference between the tropical and the temperate. This one is more destructive in nature, produce a lot of destruction, whereas in case of temperate cyclone, because it is not having that much of fast moving winds, whereas it also produce rainfall, light rainfall, that is called drizzling. Okay, which is good for the rabi crops or the winter crops. That is how it is put under the category of human friendly cyclones. Okay. Along with that, if you check out the formation, we discuss the formation, of course, this in this video we will discuss the formation of tropical cyclone. But when we talk about the formation of temperate cyclone, it's totally different from the way we're having the formation of tropical cyclone. So there you will see in some other video that the temperate cyclones are forming because of the collision of two contrasting air masses. Okay, suppose this one is cold air mass, this one is warm air mass. So when these type of air masses collide, it led to the formation of temperate cyclone. And okay, whereas in case of tropical cyclone, we don't have this kind of the action of air masses. There is some other way or the mechanism linked with the formation of tropical cyclone. So even the formation and the nature is also totally contrasting, different if we compare the tropical from the temperate cyclone. So it is not strictly, we are not categorizing strictly on the basis of the location of their formation. Even the nature and the other aspects also, like formation, are totally different from one cyclone type to another. So now we go further. So now, so our topic is tropical cyclone. Okay, So now you can easily make out the one which is forming within the two tropics usually come under the category of tropical cyclone. Okay. So now we discuss the required conditions. Required conditions for the formation of tropical cyclone. Okay. So there we're having two important or the required conditions. One is availability of or the presence of strong Coriolis force. So wherever we're having the presence of strong Coriolis force, provide the proper condition, at least fulfilling the first condition for having the formation of tropical cyclone. So first condition is presence of strong Coriolis force. Okay. Second is continuous supply of warm and moist air. Okay. Second is also very important, of course. Okay. That is the continuous supply of warm and moist air. So this both terms are important. We need to have the warm air supply and also which is carrying lot of moisture, water vapor in it. Okay, so we want to have both warm and moist air supply, right? Okay. Now, if we talk about the presence of Coriolis force, okay, so in case of tropical area, because we are talking about tropical cyclone, in case of tropical area, so most of the case this first condition fulfill more closer to the equator. Okay, right? So there this condition found more closer to the equator. Okay, so most of the case we see that the cyclones are developing closer to the equator. Okay, now the second one is if we talk about the presence of the second condition, of course, so that is very much clear. We need to have we need to satisfy both condition, that is warm air supply and also required to have moist air supply. Okay, so this proves that this condition simply proves that these cyclones cannot develop over the land area. Okay, these are the huge system, of course. This system is developing cannot develop over the land area. The reason is there we may have the supply of warm air but not having the supply of moist air. We require some ample amount of moisture which cannot be possible to have this kind of supply over the land area. Okay, I just show with the help of diagram. This map will able to make you understand the location of the formation of tropical cyclone. Mapping is very important as per the geography subject is concerned, or you can say it is one of the way of presenting yourself or your ideas linked with the geography. Right? Suppose this is the equator, almost. Okay, and they were having the Tropic of Cancer. Okay, this is Tropic of Capricorn. See, this is Australia. Okay, we know that from the center of Australia we're having the passage of Tropic of Capricorn. So I've told you most of the case we're having the formation of tropical cyclone between the two tropics. Okay, right? So even here also we're having certain reservation, of course. So it will not form over the land area. Over this part we're having the desert area. We're having a huge desert or warm desert called as Sahara. Okay, So over this part, we do have the continuous supply of more warmer air, but we cannot have the supply of moist air. Okay. In the same way, in other land areas also. So over this area, we may have the supply of warm air, but not the moist air. Okay. So there we cannot witness the formation of tropical cyclone because the conditions are not meeting. Okay. So where we can have the supply of warm and moist air, it is only and only over the warm ocean surface. Okay. So wherever we're having the warm water surface, over that part we can witness, we can think about to have the formation of tropical cyclone. Okay, that is over the watery surface, warm water surface. Okay, so in this tropical area we can have the formation of cyclone, tropical cyclone only over the watery surface. It will not form over the land surface. Okay, if you compare this with the temperate cyclone, so those cyclone can develop in any part, in fact in any kind of surface, of course, whether it is warm surface or it is cold surface. Okay, or it is watery surface. Over the land area we may have the formation of temperate cyclone. So temperate is not linking with the type of surface we are having. It is more linking with the collision of two contrasting air masses. So that is also one of the way of separating the temperate cyclone from the tropical cyclone. Whereas if you go with the case of tropical cyclone, they are developing only and only over the warm water surface. Okay. So there it talks about the location of the formation of cyclone. It is forming where? It is forming within the two tropics or within the or over the tropical water bodies or the ocean. Okay, right? Now, second is, in fact, that too, if you talk about the ocean, in case of location of the formation of tropical cyclone, these conditions are developing only over the western margins of any ocean. Okay, so if you talk about the tropical cyclone, they are forming not throughout the ocean, tropical part of the ocean, but developing on the western part of any ocean over here. The reason is the presence of the conditions, of course. Over this part we may have the formation of the tropical cyclone, but not in the eastern margin. Over this part we cannot have the formation of tropical cyclone. The reason over here is, in the western part we are having the presence of warm water surface, but in the eastern part of any tropical part of the ocean, we are having the presence of cold water surface because of the presence of cold currents. Okay, in the eastern part we're having cold currents, so over there we cannot think about to have the warm, in fact supply of air, warm and moist air supply. Over this part we're having the cold current, but here we are having the presence of warm surface, so it is simply providing the condition, second condition, that is the continuous supply of warm and moist air. Okay, so over the ocean also, tropical ocean also, only in the western part of any ocean we can have the formation of tropical cyclone. But there is one exception over there. I've told you these cyclones are developing only at the western margins of any tropical part of the ocean, western part of any ocean, of course, not in the eastern part, because in the eastern part we're having the presence of cold current. So these currents will discuss, or you will discuss, of course you will see when you cover the oceanography. Okay, so over this part we may not have the formation of tropical cyclone. Okay, but there is one exception, and that exception is North Indian Ocean, right? In case of this part, okay, so North Indian Ocean is limited up till, most of the case it is limited up till the Tropic of Cancer only. It is not reaching the polar region. So in case of North Indian Ocean, it is not having any connectivity to the polar region, so it is not having the presence of cold current. So this whole part is actually limited to the tropical area, so this whole part is having the presence of warm water only. So in case of I've told you it is not developing in the developing in the eastern margins, but that has not been applied when we talk about North Indian Ocean. So throughout this region we can witness the formation of tropical cyclone. Okay, I'll go with example over here. So this part is Arabian Sea, and over this part we're having Bay of Bengal. Okay, so this whole part this whole region of the North Indian Ocean, that is Arabian Sea and Bay of Bengal, which are the marginal seas of the Indian Ocean, this whole part can witness the formation of tropical cyclone, right? So that is how we had covered the location of the formation of tropical cyclone. They are developing in the tropical region or tropical water bodies, that too at the western part of any ocean. But there is one exception, that is North Indian Ocean. In both Arabian Sea and Bay of Bengal, we can witness the formation of tropical cyclone. Right. So we go further. I think conditions we had covered. Okay. Now we just talk about the mechanism linked with the formation of tropical cyclone. How these tropical cyclones are developing. I've told you about the required condition. Okay. So where these conditions are developing, even that also we had covered. The location we can witness the cyclone, tropical cyclones formation. Okay. But how the cyclones are forming or the mechanism, that is what we are covering over here. Right. Now it has been said that when the temperature of the water body or the surface of the water body reaches the mark of 27 degrees Celsius. Okay. So when the temperature of the ocean or the sea reaches the mark of 27, reaches near to 27 degrees Celsius, it develops a strong low pressure condition, right? So when the surface temperature reaches the mark of 27 degrees Celsius, it develops a very strong low pressure. This low pressure start attracting winds from all sides. Okay, so this is the satellite view. Okay, so they were having the region which is now developing strong low pressure because the surface temperature has reached to 27 degrees Celsius. Now it is having low pressure attracting winds from all sides, from all direction, right? Now these winds are gusting towards the low pressure region while moving. Suppose this forms example of northern hemisphere. It is developing over the northern hemisphere. So these winds, while moving towards the low pressure region, turn to their right. But this is the example of northern hemisphere. I've told you. So there, these winds are turning to their right because of the coldest force. Okay, turning to their right because of coldest force, right because of their coldest force. Okay. Now these turning of the winds hits the local wind or local air and makes them to move anti-clockwise direction in case of northern hemisphere. So this rightward turning hitting the local winds and makes the local wind to circulate around the low pressure in anti-clockwise direction. Okay, so what is happening over here? The center part is now having some strong low pressure. This strong low pressure attracts the wind from all sides. Okay, these winds, while moving towards the low pressure zone, turn to the right because it is the part of northern hemisphere. Turn to the right because of the coldest force and makes the local wind to circulate anti-clockwise direction. And this led to the formation of tropical cyclone. Okay, I've told you how can we define a cyclone? It is a low pressure zone surrounded by the spiraling or the circulatory winds. Okay, so this as a whole is called as a cyclone. Here we're having the formation of tropical cyclone, right? Now these winds, while moving towards, in fact hitting and makes the local wind to circulate, also become the part of this cyclone and start spiraling up, rising up. Okay, so that is how we're having the formation of tropical cyclone. I'll repeat again over here. So what is happening there? The surface of the water body reaches the temperature of 27 degrees Celsius or more. Because of this atmosphere above the surface witness the development of strong low pressure. Okay, so what happened? That the air come in contact with particular surface, gains the heat, become warmer, lighter, and start rising up, develop the low pressure over here. Okay, so these rising wind develop the low pressure, start attracting winds from all sides. Okay, so you know that if this part is having the low pressure, this other part will surely have the high pressure, and we know that the wind travel from high pressure to low pressure. So there, these winds are gusting or moving towards the low pressure. Okay, so while reaching over there, it makes the local wind to turn anti-clockwise in case of northern hemisphere, or clockwise in case of southern hemisphere. Okay, and even become the part of this circulatory motion and start rising up in this way. And this led to the formation of tropical cyclone. That is how we're having the formation of tropical cyclone over the sea or the western margin of any ocean. So now this is what we are having as per the formation of cyclone is concerned, tropical cyclone is concerned. Now we go with the next part. So after having the formation, what happened? These cyclones come under the influence of permanent winds and start moving in the direction of those winds. So we know that, suppose if this is the equator, okay, this is the tropics, Tropic of Cancer, Tropic of Capricorn, and we know that in this region we usually have the presence of trade winds. Okay, and these winds, trade winds, are the permanent winds which remain throughout the year, or which is having the same direction throughout the year. Okay, so over there we're having the presence of permanent winds, and these winds travel from east to west direction, okay, in this way. Okay, over here also, so what is happening? There we're having the formation of cyclone. If you go with the case of northern hemisphere, okay, these cyclone, after having their formation, they come under the influence of trade winds moving from east to west direction, and that is how under the influence of these wind, even the cyclones also start moving from east to west direction. Okay, so their cyclones travel from east to west direction. This is the east direction, suppose east, and this one is west direction. Okay, so coming under the influence of trade winds, cyclones start moving from east to west direction. Okay, from east to west direction under the influence of trade winds, which are the permanent winds. Okay, now you can apply this over the map also. You can easily understand why the eastern coast of India is highly impacted by the cyclone which are developing over the Bay of Bengal. But that is not the case of western coast of India. So this western coast is not that much influenced by the tropical cyclone, but the eastern coast is having some huge influence or having the huge impact. I'll show you. Go to draw diagram or the map over here itself. So I'll just show you what is happening in case of Arabian Sea and Bay of Bengal. This is the equator. Okay. Now this is Bay of Bengal and this one is Arabian Sea. Right. Now the cyclone which are developing over the Bay of Bengal, okay, after having their formation, so most of the case these cyclones are developing during November, December, of course. So this part remain under the influence of trade winds which are moving from east to west direction. Okay, so after having their formation, what happened? Start moving towards the west direction and hits the coast of or hits the eastern coast of India. Okay, so after having their formation, it may hit the coast of Tamil Nadu or Andhra Pradesh, Odisha, or West Bengal. Okay, or if these all be left, of course, it may hit the coast of Bangladesh. They were having Bangladesh. Okay, So in this way, after having the formation, it may follow the east-west direction path and hit the coast of hit the eastern coast of India. But that is not the case for the cyclone which are developing over the Arabian Sea. So if the cyclone is developing over the Arabian Sea, it will again come under the influence of trade wind and will move towards the west direction. Suppose it is developing over there. Okay. In that case, it will not hit the western coast of India, but travel towards the west and hit the coast of Somalia or this Arabian peninsula countries or Pakistan, the coast of Pakistan. Okay. So in this way, these cyclones are traveling and not putting any danger to the western coast of India. Most of the case. Okay. It may happen, of course, cyclones which are developing over there. It may take a curvical path and hit the coastal region of western part of India. Okay, or the western states over there. Okay, but most of the case, it is this eastern coast which are highly prone to this tropical cyclone, but not the western coastal region. Okay, right? So that is how uh, these cyclones are forming and moving from east to west direction. Now remember this one more part, that while moving from east to west direction, they are not following the linear or the straight path, but more forming the curvical path because of the action of Coriolis force. So even it has also been influenced by the Coriolis force. So after developing over there, they will not go straight, but more follow the curvical path because of the action of Coriolis force, which makes even these freely moving system to turn to the right in case of northern hemisphere or left in case of southern hemisphere. Right? So that is how we had covered the direction of the movement of tropical cyclone. So now we just check out certain features of tropical cyclone. The first feature is these cyclones form circular isobars. Okay. The first feature is, if we compare with the temperate cyclones, so these cyclones are forming the circular isobars in this way. At the center we're having the low pressure, and surrounding that we're having the formation of isobars which are in circular shape and are more closely placed even. Okay. Now what is isobar? Of course, the isobars are the imaginary line which are been made over the map, marking or simply uh, joining the places having the same atmospheric pressure. Suppose I'll go with this example. So all these dots are having the atmospheric pressure 103 millibars. Okay, so they were having a line joining the places or the dots having the same atmospheric pressure over the map. Okay, so this line form is actually demarcating one isobar. It is actually one isobar demarcating 103 millibar atmospheric pressure. Okay, so they were having the linear demarcation, but in this case we are having the circular demarcation also. There all these locations are having the same atmospheric pressure. Okay, so in this way we have demarcated these isobars having different atmospheric pressure. Okay, so the formation is more circular in this way, and this isobars, because as we move towards the low pressure, there we witness the change of low pressure more fast, of course. Okay, that is how these isobars are very closely placed to each other. But that is not the case if we talk about the temperate cyclone. In case of temperate cyclone, the isobars are more elliptical in shape in this way. It is just like having the X shape. Okay, and here the isobars are not that much closely placed. So there the isobars are very far apart, because there we see very slow change of atmospheric pressure. And so it is the example of, this forms the example of temperate cyclone. Okay, and this is the example of tropical cyclone. Even I have told you that these two are not only having just one difference of the location of their formation, but in every aspect there are these cyclones are different from the other type of cyclone. So we go with the second one. Second is, in case of tropical cyclone, you can say their walls or the boundaries are made up of some dense cloud, a huge cloud called as cumulonimbus cloud. It's a huge cloud having the height of almost 10 to 12 kilometer. That means you can see the cumulonimbus cloud quite far from the cyclone itself. It is, suppose over this part we're having the cyclone from a far distance of around 4 or 5 kilometers. You can easily see that we're having some kind of huge cloud formation. So they were having the huge cloud forming the boundary or this particular wall of the cyclone. Okay, so this cloud is called as cumulonimbus cloud. Okay, what is happening over here? So we have studied that. Suppose this is the watery surface over which we're having the formation of this low pressure system. Okay, which is attracting the wind from all sides, and these winds are warm and moving over the warm surface. Okay, we're talking about this particular cyclone, this cloud formation. So now while moving towards the low pressure zone, what is happening? This warm air or the winds absorbs lot of water vapor, because we know that warm winds are usually having some higher capacity to absorb water. So that is how these winds are warmer, and while moving over the surface, watery surface absorbs lot of water vapor. So over this part we are witnessing the evaporation. Right, okay. Now after becoming the part of this circulatory motion or this winds, of course, what happened? These winds start rising up very fast. Okay, so because of the fast spiraling winds, what happened? These winds become the part of the cyclone and start rising up, and that too very fast. And because of this rising towards the upper atmosphere, what happened? There we witness the decrease of temperature, and this water vapor suddenly condense and led to the formation of this huge cloud. Okay, and this cloud actually looks like the wall of the tropical cyclone, seen from the far distance from the cyclone. Okay, it is these clouds only which actually produce very heavy rainfall, which when reaches over the coastal areas develop, produce torrential rainfall and develop the flooding conditions. Okay, so it is these clouds only which simply develop, produce the torrential rainfall and almost creating the flooding condition along the coast where it witnesses the landfall. Okay, so this cloud has been named as cumulonimbus cloud. Nimbus stands for the rain bearing cloud, and cumulo stands for a huge heap, there, mound. Okay, so this is the cumulonimbus cloud, which is one of the feature of tropical cyclone. I'll go further with the features only. Now, third is, now during the formation of tropical cyclone, initially the speed of the speed of the circulatory winds is somewhere closer to 30 to 40 kilometer per hour. But with the further development, what happened? The speed may even cross the mark of 180 kilometer per hour, and even crosses the mark of 220 kilometer per hour. Okay, see that such a high speed we're having, that of the circulatory or the spiraling winds. Okay, and this speed is really very destructive when the cyclone falls over the coastal areas. Okay, it produces lot of destruction. It's a very high speed, of course. In this speed, almost it create lot of destruction, lot of losses we witness of both property and life because of this high speed. Okay, if that is so, if this cyclone crosses the mark of 220 km per hour, in that case, there we put this particular tropical cyclone under the category of extremely severe tropical cyclone. Okay, so on the basis of the speed of the circulatory winds, we categorize the cyclone as the low pressure zone, depression, deep depression, severe cyclone, or extremely severe cyclone. Okay, so if the speed crosses the mark of 220 km per hour, then it will be put under the category of extremely severe tropical cyclone. Okay, whereas if you go with the case of tempered cyclone, we are not having such a high speed of the circulatory winds in case of tempered cyclone. Okay, so there normally we're having the speed somewhere closer to 30-40 km per hour of a well developed tempered cyclone. So see the speed, the maximum speed of tempered cyclone and the maximum speed of tropical cyclone. That is how it is not that much destructive. The speed is not that much fast, which can create destruction. Whereas the speed of tropical cyclone is usually very fast, may have the capacity to make lot of destruction over the coastal areas. Okay, so this is another feature which segregate tropical from the temperate cyclone. I'll go with one more feature. So I've told you this cyclone is having the cumulonimbus cloud. These are the cloud which is having some high capacity to produce flooding along the coast or produce destruction. Okay, in the along with that we also have very high speed of the circulatory winds. Okay, so because of this nature, what happened? It simply give another feature of the tropical cyclone, that is it is more destructive in nature. We had already covered destructive in nature. Okay, so above two feature forms or help in the development of the fourth feature, that is destructive nature of the tropical cyclone. Okay, so whenever this cyclone reaches the coastal area, suppose this is the watery area. Okay, so when these cyclones simply makes the landfall over the coastal areas, it produces lot of destruction because of not only because of the fast moving speed, but also because of the heavy rainfall, which develop almost the flooding condition over there along the coastal areas, which is witnessing the landfall of the tropical cyclone. There's one more feature of tropical cyclone, and that feature is most of the case these cyclones are developing in equatorial low pressure zone. Okay, so low pressure, in case of equator we're having the low pressure region because of the warm conditions. Okay, so there the cyclones are developing in or within the equatorial low pressure zone. Suppose this is the equator line. Okay, and this closer to the equator we're having the equatorial region, okay, which is having the warmer condition. Okay, so there suppose we're having the equatorial region. Okay, right, so equatorial low pressure region. Now these cyclones are developing within the equatorial low pressure zone. Over here we can witness more formation of tropical cyclone over this part, right? Even it is also having another name, what you would have you might be knowing when you had if you have covered a very important topic of geography or the geography of India, that is monsoon. Okay, so they were having one important concept called as intertropical convergence zone. Okay, so between the two tropics we're having the convergence of trade winds or the winds, of course. That convergence zone is nothing but the low pressure zone. There the air winds are coming and rising up, creating the low pressure called as intertropical convergence zone. It is nothing but same equatorial low pressure zone. Okay, so there the winds are coming and converging and rising up, creating the low pressure. Okay, so it is also having another name that is called as intertropical convergence zone. So most of the case we witness the formation of tropical cyclone within this equatorial low pressure zone or intertropical convergence zone. Okay, so this forms the fifth feature of tropical cyclone. Now the next one. So we had covered certain important features of tropical cyclone. We go with the next part of tropical cyclone, and that is linked with the naming of the cyclones. Okay, so this is the condition, this is the weather phenomenon or the system which develop throughout the world in the tropical areas, of course. Okay, now these cyclones are having different names in different region of the world. Like it is called a cyclone if you go with the case of India, Indian subcontinent. Okay, so over this region it has been termed as cyclone. Okay, so in the same way we're having certain more names or nomenclature of cyclone, of tropical cyclone. First one I've already made, you know, it is called a cyclone. Cyclone in case of Indian subcontinent. Okay, it has been termed as Willy Willy. Willy Willy in Australia. Australia, called as Baguio. If you go the region of Philippines, okay. In case of South China Sea or China, China has named it as typhoon. Typhoon, China. Typhi or Taifu in Japan. And there's one more name, that is hurricane. Okay. So in both the Americas, it has been it is known with the name of hurricane in America, that is South America and North America. Okay, so between that we're having a, between these two islands we're having a region called as Gulf of Mexico. Okay, so it is between the northern part we're having North America, southern part we're having South America. Between that we're having a engulfed region or the you can say enclosed region. Okay, so over there we're having more warmer water, providing very good condition for the formation of tropical cyclone. So over that part we're having the regular development of this kind of low pressure conditions, okay, or low pressure system called as hurricane. So these are various names which are there throughout the world. Okay, I'll show you with the help of map, even drawn one map that I can show you. Yes, this one. This is Gulf of Mexico. Again, a very important region as per the development of tropical cyclones are concerned. Okay, so this area, this is the region of Indian subcontinent or the northern part of Indian Ocean. Okay, over this part it has been named or is known by the name of cyclone. Okay, this is Australia. Over this part we may have the formation of, we can witness the formation of cyclone. So there Australia has given the name Willy Willy. Okay, this is the region of Philippines. Over this part Philippines is having a different name called as Baguio. This is the region of South China Sea. South China Sea. So China has named this particular system as a typhoon, and there we are having the Japanese region, of course. Oh, this is Japan. So if it's developing over here, okay, then it is called as Typhi. Okay, remember this part. Even though it is quite beyond the tropical region, but they were having the presence of warm water, warm current. It is also developing the conditions, providing the condition for the development of cyclone. That is how even Japan is also, it may have some influence. Okay, so there it is called as Typhi in case of Japan, and this is the location which is having the name hurricane. So that is how we had covered the nomenclature, the different names of tropical cyclone. Now, I just give you some examples also. Okay, linked with the recently developed or the last year we had witnessed certain cyclone formation. Okay, some of the known are, we're having cyclone Shakti. Okay, in the tropical areas we're having, or in Indian Ocean we're having this cyclone formation in 2025, and this name was given by Sri Lanka. Okay, there's one more cyclone. It's called as cyclone Ditwa. This cyclone formed in Arabian Sea, over the Arabian Sea. Okay, and it was named by Yemen. There's one more cyclone, or we're having one more example, that is hurricane Melissa. Okay, so this is the example of cyclone develop over the Gulf of Mexico. Okay, so these are certain examples what we had seen uh, uh, in the form of tropical cyclone developed in the year 2025. So now with this example, I just end my lecture. Hope that you would have understood all the aspects of this important topic, tropical cyclone. Thank you so much for your time.